Welcome to this lesson on job schedulers. In this lesson, I'm going to talk about what a job scheduler is, why they're needed, and then talk a little bit about the Slurm workload manager in particular as a concrete example. So first off, what is a job scheduler? It's simply a program that will manage your shared resources, the compute nodes, and also categorize them. Basically, it knows what the compute nodes are, what's available, how many CPUs they have, how much memory they have, if they have GPUs, and it will group them together according to how the HPC center wants. You might want to have a group of like interactive compute nodes and make sure that those are associated with each other. The job scheduler will do that, so then people can submit a job to the interactive queue. It also will organize and prioritize resource requests, basically jobs and job requests. What this means is it keeps track of all the jobs on a system, when a job was run, what the script name was, who ran it, assign a job ID to it, and how long it ran. And that will also prioritize the requests that people have made if there needs to be a wait. Say like all the compute nodes are currently in use, it will try to prioritize submitted jobs. So why are these job schedulers needed? Quite simply, there's a finite amount of resources. No matter how big an HPC cluster is, there's almost always more work that people want to run on it than there are resources available. And you can't really have everyone trying to run everything all at once. So you need some way to schedule jobs and prioritize them. Additionally, too, you wouldn't want to have to kind of sit at your laptop waiting for a compute node to be available to use it. So with the job scheduler, you can submit what's called a batch request, send the job to the job scheduler, and walk away from your machine, and your code will be run. Additionally, HPC centers want to both have something that handles prioritization of jobs. You don't want someone's job to be looking through what people are requesting and trying to prioritize that on the system. And then also keep track of usage. This can come up for a couple different ways. Some of it is, an HPC center might want to make sure that their resources are being used, or you might have usage limits. Projects are assigned a certain amount of hours and they want to keep track of how many hours a project is used and then cut them off if they hit their limit. Finally, just a couple of common job schedulers are Slurm, LSF, and Torque. In this lesson, we're going to be focusing on Slurm. Main reasons we're doing this is it's open source, so free and open source, so that being available is great. Everyone can download it if you want to run it on your own machine to run some tests. It's also used by about 65% of HPC clusters in the top 500 list. If you don't know what the top 500 list is, it is the top 500 fastest HPC cluster supercomputers, in the world. So 65% of these use Slurm. We also use it here at UAF. So as further lessons go, as we do further lessons, this is what you'll be using. And finally, the concepts that we're learning here are pretty similar across all job schedulers. In fact, Slurm has a Torque module that you can install that allows you to use the Torque commands to run Slurm stuff. So very common concepts across all of them. So first off, to give an overview of Slurm, the two things that it kind of does is it defines multiple aspects of the cluster, and then it also handles the job submission and the actual resource allocation. So what does this mean? So when I say it defines multiple aspects of a cluster, what I mean is it defines the nodes available to the cluster, what CPUs, GPUs, etc. are available, how many nodes are available, and then it will define the partitions, which are specific sets of these nodes, which we'll talk about in a little bit about what that means. And also like the quality of service that are available to users in Slurm users and for job submission. The quality of service is just another way to tweak the prioritization and how jobs run in the cluster. It also keeps track of accounts and job information. So you need to have an account in Slurm to be able to submit jobs to the HPC cluster. And by job information, it holds basically any information about a job. When it ran, when it finished, did it actually successfully complete or did it error out? Who ran it, what the script name was, it'll assign a job ID, all of that. And then also two kind of important things that it keeps track of as well is the fair share, which I'll talk about in a bit, but it's a number that helps prioritize jobs in the queue if all the resources are currently being used. It'll help determine what's being launched next. And also the GPU, CPU hours, minutes, how many minutes or hours of GPU usage has occurred. This usually comes into play if there's a limit on the amount that a project can use. And when I say it handles job submission and resource allocation, what I mean is it will prioritize job requests. It will handle taking the job request from a login node, moving a job to the compute nodes, running what your script says, running what your commands are on the compute nodes, and then like bundling up output and things like that to get back to you. For the prioritization schemes, multiple types are available. Partitions and quality of services might factor in, and fair share and CPU GPU hours may also be used to limit if and when jobs can run. So first off, when I say Slurm deals with node definitions, what I mean is it keeps in mind the number of sockets, CPUs, threads, memory, and then also you can define custom features in Slurm. And what that means is you can say, hey, this node has this processor type, or this has a GPU attached, or it has this much memory, like a big memory, a large amount of memory, or it has hyperthreading available. And then when you submit jobs, you can key off of these features. So you can define a constraint saying, I need this processor type. So this image is an example of UAF's nodes, just an example of 3 different types of nodes. When you run this sinfo command, this sinfo-nel command, you can give it node names, and it will display the node name, the partition that it's in, what state it is, if it's like allocated, if it's idle, if it's down, the number of CPUs it has, the number of sockets, CPU, and threads available, the total amount of memory in kilobytes, this avail_fe is the features that I was talking about. At UAF, we only have features for processor types. So this is Haswell, Broadwell, and Sapphire Rapids Intel processors. So if someone needs to submit a job that can only run on the Sapphire Rapids, they can use a constraint to say, hey, I only want these nodes. Right. And then partitions and QoSs, quality of services, are mainly used for both prioritization or to kind of constrain what nodes people can run on. Partitions are mainly used for the kind of node constraint, and quality of service is more about the prioritization, the preemption of jobs, and limiting resources. So partitions, as mentioned before, are used to group nodes into a set. What I mean, you can give it a list of compute nodes, saying like nodes 10 through 30 are part of a interactive queue or interactive partition. And that means that those nodes will be used interactively, that people can submit jobs to the interactive partition, and they will only run on nodes 10 through 30. Partitions can overlap. So if you have multiple partitions that are used for different things, they can overlap. You can have nodes that are in multiple partitions. So say nodes 10 through 20 are in the interactive partition, and 10 through 20 are also in the debugging partition. And so those nodes will be available if you submit to either of those partitions. And you can create partitions that are based on what I'm going to call technical or organizational factors. So what I mean here, you can create a partition that's, say, based on all the fact that all these nodes share the same hardware. Like I have a GPU partition, so all the nodes in this GPU partition have to have a GPU. Or it can be an organizational factor. I have a biosciences partition, and only members of the biosciences groups or projects can submit jobs to this partition. And then you can limit what partitions are seen by different groups or all sorts of things like that. Quality of service is something that you can attach to a partition or an account. And basically, you can say, hey, being a part of this quality of service bumps or lowers your prioritization. Jobs in this quality of service can preempt other jobs. So, say you work at a place that does weather forecasting on an HPC cluster and a storm's coming in. There might be an urgent QoS where they submit a job using this urgent QoS that will preempt jobs that are doing like a forecast for 10 days out, because that's not as important as knowing what exactly this storm's going to do tomorrow. So a QoS can do that, and it can also limit resources. You can also use a QoS to restrict partition. So if a group is a member of a QoS, maybe certain partitions are only available to that QoS. So only groups who are part of that QoS can see that partition. And I'll show an example of that in a moment. So these are UAF's partition. It's just a small subset. So we have a debug partition. So you can see this like partition name, the nodes that are in it, the max time that a job can run. In this case, for the debug partition, the max time is only 1 hour, so a job will end after an hour. The max nodes, so this is the max number of nodes you can request in a single job request. So that does not mean that a user can only have 3 nodes total when submitting to the debug partition. It means that a single request can only use up to 3 nodes. So you can have you can have like 4 one node job requests here, and those will all run if there's resources available. But you can't have a single job request that requests 4. The state is just the default state when Slurm is restarted, what allow groups or what groups are allowed on it. And then there's some priority information. Oversubscribe is how many jobs can run on nodes in this partition. Is the partition hidden? And is it the default partition that if you forget to specify what partition you're submitting to, will it submit to this one? And then we also have like the T1 small. You can see that it has a larger node list. The max time is 2 days. The max number of nodes is 2. And then on the flip side, we have this T1 standard where it specifies a minimum number of nodes. You can only submit jobs that are 3 nodes or more on this one. And so that's just kind of an example of what partitions might look like and what sort of information is available. Finally, I want to talk a little bit about fair share and allocations, prioritization and allocations. Almost all job schedulers have some way to prioritize jobs. Some of it is based on when a job was submitted, but kind of 2 key things for kind of making the resource usage fair are fair share and trackable resources. So fair share is a ratio between how many resources you're assigned and how many of you've used. So in Slurm, you might be assigned, like your group might be assigned 100 shares, and there might be 1,000 shares total available to the cluster. So based on how many of those 100 shares that you've used, it will create this ratio that will then help determine your job priority. So it won't, if you've used, say, like 1,000 shares worth of stuff and you're only assigned 100, this fair share value will be very small. So you've used way too many of your resources, and so your job priority tanks, and it may take a while for your job to launch if other people have used less of their fair share of resources. Trackable resources are another way to kind of limit how many jobs someone can run. So basically, at these sorts of centers, a project might be allocated a certain amount of hours of CPU, GPU, memory usage. These could either be individual or like some combination of it, weighted differently. So, like GPUs might cost twice the trackable resources as a CPU, and memory like half as much. And so each time you run a job, it will keep track of how many CPU hours, GPU hours, and memory hours or minutes that you've used, and once you've hit your limit, you're no longer allowed to run jobs. And both of these are ways to try to kind of fairly allocate resources. And that about sums up the what a job scheduler is, how it kind of works on a non-technical level. In the next lesson, we'll do some examples about how to actually submit jobs to a job scheduler and get a bit of information from it. Thank you.